Hi, I'm Danae Brazel, Vice President and General Manager of KIN-TEK Analytical Incorporated. Today I'm going to cover identifying the right permeation tube for your application. A short story of permeation tubes. Permeation tubes have been around since about 1966, when it was still very difficult to control temperature of a device to plus or minus 0.1 degrees C effectively, or to measure gas analytes at sub-ppm concentration levels. Some of the early work done with permeation tubes revealed that permeation tubes could be used for dispensing a very low stable flow of pure analyte gas, which could be diluted further and used for calibration if made properly. Back then, a short list of analytes were studied, but today, a list of over 550 different analytes exists for use in a permeation device. However, the permeation tube is still not a well-known device. Many people aren't even aware of the advantages of permeation tubes or how they work to apply to their application. To aid in understanding, a short, quick overview is provided about trace source permeation tubes and their use for different applications. Introduction is, first of all, trace source permeation tubes are small devices for creating niche traceable gas standards and are typically used for calibrating gas analytical devices, but can be used for much more. Understanding how permeation tubes work and the different types available broadens their use in different applications. A basic overview of the trace source permeation tubes and their capability is provided in this slideshow. So what is a trace source permeation tube? A trace source permeation tube is a device that consists of a polymeric membrane that provides a controlled barrier for dispensing pure chemical component. The pure chemical passes through the polymeric membrane at a measured rate when held at a constant, stable temperature. Trace source permeation tubes are extremely effective at controlling the tiny flow rate of pure gas across the membrane that would otherwise be difficult to measure by conventional methods. Physical characteristics of the membrane, such as a thin membrane shown in picture A, a thick membrane shown in picture B, or varying the type of membrane, helps control the emission rate of the analyte when the operating temperature is stable. The product of the solubility of pure chemical compound through the membrane and the diffusivity of the compound through the membrane define the mechanism of permeation as a function of temperature. So as you can see here, we have a thin membrane wall that is allowing the permeation of the gas to go through. If you thicken the membrane, then you see that it slows down the permeation of the gas molecules. And in the case of changing the type of membrane, you can also control the emission rate across that membrane at a stable temperature. These are all done at a stable known temperature. Think of permeation like making tea. Imagine making a nice cup of tea when the water is hot and the tea permeates the bag and makes a nice cup of tea in a few minutes. When the water is cold, it takes much longer for your tea to make because permeation is slow. This means it's temperature dependent. For permeation tubes, the trace source permeation tubes have two different categories. We have disposable type tubes, and then there are refillable type tubes. Disposable tubes consist of short lengths of Teflon tubing that are filled with pure analyte. It's a small amount of the pure chemical compound that goes inside of it. The component analyte then permeates from the inside to the outside of the tube. With the refillable type tubes, this consists of a stainless steel cylinder with the internal tubing. The pure chemical compound in the cylinder surrounds the membrane that's held inside the refillable tube, and it permeates from the outside to the inside of the membrane. With this type of tube, typically we would have a nitrogen carrier gas or some type of zero air carrier gas circulating through the internal membrane and picking up that compound analyte that is passing through that internal membrane. So it permeates from the outside of the membrane to the inside, and then picks up, the dilution gas picks up the permeate gas and takes it back out to the system. Different types of trace source disposable permeation tubes are also subdivided into further categories. So for the disposable, which are Teflon membranes, this can hold liquids or solids, and they are subdivided into what we call an HRT, SRT, SRT2, an EL, etc. And depending on these types of part numbers will vary the type of Teflon or the thickness of the Teflon to provide the emission rate needed for an application. The refillable tubes are further subdivided into a gas-fed, a gas-filled, or liquid-filled, which carries the part numbers of LFH, 57S, or 57H. So depending on the analyte properties and how the permeation works will dictate if it's going to be a disposable or a refillable tube and what the application needs. So further talking about disposable permeation tubes. In the disposable permeation tubes, as mentioned, they are filled with the pure analyte, such as benzene, acetone, H2S, and so on and so forth. They're going to be sealed at each end, and they contain the analyte inside the tube. Now, with that said, the length, the type, and the thickness of the membrane, which is typically Teflon, provide surface area controls. The operating temperature directly affects the flow of analyte of gas across the membrane, which is then given as the emission rate. So the analyte's contained inside and it permeates to the outside. This is a small measured flow measured by gravimetric weight loss and given in nanograms per minute. So that little F is basically the rate across the membrane that's provided across the membrane in nanograms per minute. So to understand some of the differences in disposable permeation tubes, you can look at the type of Teflon, whether it be TFE or FEP, the wall thickness, and the lengths of the tubing that is provided. So that's how those controls work to allow a certain emission rate out of the permeation tube. For example, a 2 centimeter HRT tube of, say, water at 40 degrees C may give 4 ppm concentration, while a 2 centimeter SRT tube may give 2 ppm at the same temperature. So different types of membrane, control output, different lengths of membrane, so on and so forth. So how does it really work? When you put a permeation tube inside of an adapter bottle or a glass bottle to contain that disposable permeation tube, a typical permeation system will have a carrier gas that is introduced to pick up what's crossing the permeation tube membrane. So that analyte gas that's crossing the membrane is going into the adapter bottle, and the dilution flow, which is usually nitrogen, is picking up what's being permeated. So disposable tubes are contained in a glass adapter bottle, and their emitting gas is swept by the dilution carrier gas out to the system. The resulting concentration is based on the calculation of the emission rate times the K factor, and then divided by the total flow. That's your total dilution flow. The effects of temperature of permeation tubes. Permeation tubes are temperature dependent, and they are certified at a controlled temperature to plus or minus 0.0 degree C, 0.05 degrees C, to establish the emission rate. Variations in temperature directly affect the emission rate of the tube. So you can see here, generally a 1 degree C change in temperature causes about a 10% change in tube emission rate for liquid-filled tubes at lower temperatures. Okay, as you get to higher temperatures, most compounds or most analytes, the emission rate is going to change logarithmically with the increased temperature. So this is an example of an acetone tube showing a little bit of a doubling rule as we get through go to higher temperatures. From 30 to 60 degrees C, but as we get into even higher temperatures, the permeation rate across the membrane of one type of disposable tube may vary in a way that you get a logarithmic change. The effects of flow are a little bit different on permeation tubes. Changes in dilution flow have an inverse effect on concentration level. So as the flow is increasing, the resultant concentration decreases. So you're mainly diluting what is coming out of the permeation tube. So those changes in flow are going to be linear with relation to the concentration, and the variation of the flow have no effect on the tube emission rate. So the tube itself is certified to provide an emission rate, and then changing the dilution flow mainly just changes your output concentration. So precise and accurate flow control provides an effective delivery of gas for analysis. The certified permeation tube in the system. Liquid or solid filled trace source permeation tubes are gravimetrically certified based on weight loss at a known controlled temperature to provide the average emission rate, typically in nanograms per minute. These certified tubes are NIST traceable through fundamental standards such as weight or temperature control. So when the tube is weighed, it's done on a balance that has been certified and traceable to NIST, and the temperature of the oven has been certified and traceable to NIST through fundamental standards. KIN-TEK instrument components also have oven and flow control that use permeation tubes, and those components are also NIST traceable and certified via flow and temperature standards. So this is how the NIST traceability comes into play. So certified standards are NIST traceable because they are the result of a measurement or the value of a standard that is related to stated references. In this case, in the US, we use the National Institute of Standards and Technology, and this is done through an unbroken chain of comparisons, all having stated uncertainties over a limited time period. So the certification is done. For higher concentration levels and high vapor pressure gases, trace source refillable tubes are used. These are stainless steel cylinders with the membrane inside. They consist of a liquid, solid, or gas fed, and they hold longer membranes inside to provide higher emission rates beyond that of disposable tubes. In the refillable tube, the compound surrounds the membrane and permeates from the outside of the membrane to the inside. Some analytes may be refilled by the user depending on what compound is contained inside of it. But the object here is that it creates higher concentrations that are NIST traceable standards. Where a disposable tube would leave off, we have a higher level of emission rate that can come out of a longer membrane. In the case of the gas-filled tubes, that membrane is still up to 10 centimeters. One refillable tube can be used per permeation oven. So the differences in the trace source refillable tube is that 57S tubes, again, are those high vapor pressure gases. You can get concentrations into from sub ppb to 10 ppm. So parts per billion up to 10 ppm, so parts per million. Tube lengths are usually between 0.01 to 10 centimeters. Now, when we get into the high vapor pressure gases, we can also have, there's also the 57H refillable permeation tube, where it extends what can be done in this type of tube, and it requires different controls to get between 10 ppm to 1,000 ppm, or even more in some cases, depending on the analyte. Because that membrane can go from 10 centimeters to 2,000 centimeters, those higher concentrations can be achieved. Same thing with the low vapor pressure liquids. Anywhere between 10 ppm to 1,000 ppm can be achieved, sometimes higher, and that's, again, relative to the length of membrane inside the refillable permeation. So when talking about the equipment used with trace source permeation tubes, the permeation tubes are going to require excellent temperature control. They require accurate and precise dilution flow control. So a mass flow meter or a mass flow controller with, say, plus or minus 1% full scale tolerance. And for calibration, NIST traceability of equipment components is necessary. KIN-TEK Analytical offers over 550 different chemical components and the precision equipment to operate them. KIN-TEK permeation systems, which are gas standard generators, include a broad range of instruments designed specifically for the variety of applications that we serve. One of the applications that's quite typically used with permeation tubes is moisture analysis. So trace moisture analysis in manufacturing and industrial applications is important for quality assurance. Water is ubiquitous and a contaminant even at parts per billion or lower concentrations. Equipment and permeation tubes for trace moisture calibration is determined by the level of moisture required for analysis. For example, there's different models of moisture standard generators that provide different levels of concentration. So a single oven SpanPack 61 H2O unit may provide 100 ppm to 100 ppb of concentration using a refillable LFH or disposable water tube. For higher range or different ranges of concentrations, the SpanPack 261 H2O is used. And as you get to lower concentrations or different variations of those applications, the different equipment is incorporated to provide the level of moisture concentration needed for analysis. Another application that uses permeation tubes is gas chromatograph mass spectrometer calibration. Permeation tubes are often used for calibrating a GCMS for determining unknown components and quantities of gas mixtures, or for building a library of component peaks such as sulfurs. All types of trace source permeation tubes are available for use in equipment such as the FlexStream modular permeation system, the 491 Flex modular permeation system, or the standalone EcoFlex. For process GCs, the SpanPack industrial permeation system also employs both disposable and refillable type tubes. So permeation tubes, all the different types, can be used to create a broad range or broad mixtures or broad levels of calibrations. Other important applications that use trace source permeation tubes are research and development. Improved methods of gas detection or analysis are always being researched for developing increased sensitivity to detect extremely low gas concentrations. So trace source disposable permeation tubes are a reliable method to dynamically generate ppb and lower NIST traceable gas standards for a variety of analytes such as VTEX, benzene, toluene, ethylene, ethylbenzene, and xylenes for environmental gas analysis. So depending on the mixture needed, up to 8 disposable permeation tubes can be operated together at the same temperature in one oven, or you can add additional oven modules to accommodate a variety of analytes needed for a broad mixture. So for example, an LFH refillable, a 57S gas filled, or disposable tubes can all be used in a series of modules and diluted from hundreds of ppm to ppb, depending on the equipment. So creating known trace gas concentrations to determine exposure limits of filter materials can be done. You can also create known trace gas levels to use in animal model experiments, or even to verify absorbent materials, as well as any other type of R&D applications like sensor development or detector development or sensitivity of sensors or different types of sensors that are being developed. So using both refillable and disposable tubes can generate the various gases needed to quantify those results. Trace source permeation tubes have many advantages. They dynamically generate a fresh gas standard with each use instead of using a static gas mixture in a big cylinder, and one tube can replace several gas cylinders. They're small in size, as most disposable tubes are less than 15 centimeters in length, and while the refillable tubes are only about 6 to 8 inches high. They are easy and safe to use, easy to handle, and easy to store. They provide a low concentration standard traceable to the National Institute of Standard Technology. So multiple disposable permeation tubes can be used at the same temperature to easily create a mixture, say up to 8 trace source disposable tubes in one KIN-TEK permeation tube bottle can be used. So several advantages to using permeation tubes all come together to create the best possible system. So in conclusion, permeation tube technology has been around for many years, but there's still a lack of understanding of the broad range of applications they serve. Understanding different types of permeation tubes available helps to identify their use for a specific application. There are many applications in which these extraordinary little devices are used. Some are mentioned, but it would be hard to list all of them. In general terms, Whenever ppm gas concentration or lower is present, being analyzed, being detected, or is needed for exposure testing, permeation tubes should be used to ensure the trace concentrations are quantified. Thank you for listening to my presentation. Again, my name is Danae Vrazel. I'm the Vice President of KIN-TEK Analytical, and we hope to see you soon.